Bright QT. Every student matters.
Now a basic question. Find the decimal expansions of 10 by 3, 7 by 8 and 1 by 7. To find decimal expansion of 10 by 3, I will perform the long division that we do in. Now to perform the long division like we did in the previous classes, what I will do is I will divide 10 by 3. So 3 3s are 9, and what is the remainder? Remainder is 1, right? Now remainder is lesser than the divisor, so what I will do is I will place a decimal here and a 0 here. Now again 3 3s are 9, so again 1 is your remainder. Now I will put a 0 here because I have already put the decimal here. This is how we divide numbers. Then again 3 3s are 9, and then again 1 as remainder. So this will keep on repeating. So I am getting 1 as my remainder after every step, and this will keep on going like this, 3.33333. So 10 by 3 will have decimal expansion of 3.33333 and so on, or what you can do is you can write it as 3.3. The repeating block is only this number, so I will put a bar on it. So 3.3 bar. So this is the decimal expansion of 10 by 3. Now let us look at the next number, 7 by 8. Again the division process, 7 divided by 8. Now 7 is already smaller than 8. Okay, so what I will do is I will put a decimal here and then a 0 here. Okay, now 8 8s are 64, 6 is the remainder here. Okay, now I will put a 0 here. Okay, 8 7s are 56, then I will have a 4 here, put a 0, 5, 40, and then the remainder is 0. So this number will terminate here itself, right? So 77 divided by 8 can be written as 0.875. Okay, this is a terminating type of decimal expansion. It doesn't involve any bar, etc. Okay, and it terminated after 3 digits, right? And you will notice that the number will terminate after certain block of numbers, right? In this case it terminated after 3 digits. Whatever the divisor is, if the divisor is 8, it will have maximum 7 digits. Maximum 7 digits. Maximum doesn't mean that it will always have 7 digits. In case of 8, it will definitely have 3 digits, because 8 is 2 raised to power 3, right? We can multiply it by 5 raised to power 3 and the numerator by 5 raised to power 3. We know that this is 1000. Okay, so this number when divided by 8, any number when divided by 8 will terminate maximum after 3 digits. But in this case, to generalize this, I can say that if I divide a number by a certain divisor, let us say by 13, it will terminate after 12 digits maximum. Okay, so this is what we will notice while dividing these. 1 by 7. Now I am dividing 1 by 7. So what I can predict here itself is that it will terminate after 6 digits. Block of. Now when I divide 1 by 7, it will start repeating after a block of 6 digits. So any number will either terminate after certain block of digits, or it will start repeating after certain block of digits. In case of 7, when I divide a number by 7, right, it is not, the denominator is not exclusively 2 raised to power m into 5 raised to power n type. So it will start repeating after certain number of digits, and it can have maximum 6 digits in the repeating block. It cannot have 7 digits because the divisor is 7 and the repeating block, number of digits in the repeating block has to be lesser than the divisor. Okay, now 1 divided by 7, so 0 point, I can write a 0 here, 1, 7, 3 is the remainder, 4, 28, 2 is the remainder, so I will take a 0 here, 2, 14, 6 is the remainder, so again a 0 here. 8, 56, 4 is the remainder, so I will take a 0 here. 5, 35, 5 is the remainder, I will take a 0 here. 7 sevens are 49. 1 is the remainder. Look, we started with 1 here because we divided 1 by 7, right? So we started with 1 here, I have got 1 again. So after this, what will happen is 1, 4, 2, 8, 5, 7 will start repeating. So this is my repeating block of digits 1, 4, 2, 8, 5, 7. And how many digits has it got? 6 digits. So 1 by 7 can be written as 0.142857, right? Then I put a bar on it. Now these were the decimal expansions, some of the decimal expansions. Now let us look at this number. Show that this number is a rational number. Now you look at this number, this is a terminating type of decimal expansion. It terminated after 6 digits. So it definitely is a rational number. To show it to be a rational number, I need to write it in P by Q form, right? Every rational number can be written in P by Q form, where Q is not equal to 0 and P and Q are integers. Now look at this. This number 3.142678 is equal to 3142678. How many numbers are there after the decimal? 6. So what I can do is I can write it like this: 1, 2, 3, 4, 5, 6. So this number can be written as this P by Q form. Now see, the denominator and the numerator. Denominator is not 0 and it is an integer. Numerator is an integer. So this is P by Q form. Hence the number 3.142678 is a rational number. Okay. Show that this number can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now the number that we have is 0.33333 and it continues like this. So we put a bar on the repeating part, that is 3. Now let us assume that this number is equal to x. Okay. This is the process that we will follow in such kind of repeating numbers to write them in P by Q form. I assume that number to be equal to certain variable or alphabet. I have taken x here. If x is equal to 0.3 bar, now look at this. If I multiply both sides by 10, 10x will be, now this will be 3.3333 and so on. If I multiply this number by 10, this decimal will shift one place to the right. So this number will be this, which is 3.3 bar, right? Now if I consider it my equation 1 and this as equation 2, subtracting 1 from 2, I will have 10x minus x, that is 9x. It is equal to 3.3 bar minus 0.3 bar, that is 3. Okay. The purpose of this process is to eliminate the repeating part. How can I eliminate the repeating part? By bringing this to the left hand side, the repeating part to the left hand side. What will happen in that case is, if I, let us say only one digit is repeating, if I multiply it by 10, what will happen is this digit will come to the left of this decimal and on the right I will still have these 33333 and so on. Now once I subtract these, I will have a number without the bar, without the repeating block. So now x can be written as 3 by 9 or 1 by 3. So this is the expression in form of P by Q for this number, that is 1 by 3, right? Now let us look at this number. We will again assume it to be equal to x. So 1.27 bar, let us assume it to be equal to x. which number should I multiply it with? I need to eliminate 2 7 here, right? So what I need here is I'll multiply this by 100. Okay, so this number will become 127.27 bar. Okay, now see, this repeating block is still there. This was here itself. The repeating block is still there. So now if I subtract 1 from 2, this repeating block will get eliminated. 99x will be equal to 127 minus 1, that is 126. Repeating block got eliminated. So our entire purpose is to eliminate the repeating block of numbers. So x is equal to 126 by 99, right? And if you notice, in the first one there was one repeating number, right? There was one repeating digit, and we got our answer as that digit divided by 9, right? In this I got two repeating digits, so I got 2 9s in the denominator, and in the numerator I got the number, that is this number minus this. Okay, the number 127 minus 1. Okay, now we have got a number where we have got a repeating block and a digit which is not repeating. So let us assume it to be equal to x, 0.235 bar, right? Now first thing I'll do is I'll bring this non-repeating number before the decimal. How can I do that? I multiply both sides by 10, so it will become 2.35 bar, right? Let it be my first equation. Now which number should I multiply it with to bring this repeating block before the decimal? I'll multiply both sides by 100 of this equation, right? So this will become 1000x and it will become 235.35 bar, right? Because if you look at this number, this is 2.353535 etc. If I multiply this by 100, what will happen is it will become 235.353535 and so on. Okay, so now let it be equation number 2. If I subtract 1 from 2, I'll have 1000x minus 10x, that is 990x, and here I'll have 235 minus 2, that is 233. Okay, so x will be equal to 233 divided by 990. And you notice in the previous p by q forms we had only 9s in the denominator. In this one we have got a 0 also. Why this 0? Because of this non-repeating number. Okay, and you will notice when you go further that you will have as many zeros as the non-repeating digits after the decimal. Okay, and you will have as many 9s as the repeating digits, and in the numerator you will have a difference of this number 235 and this non-repeating number 2. So 233 by 990 in this case is your answer, right? Find an irrational number between 1 by 7 and 2 by 7. 1 by 7 we just calculated in our examples is equal to 0.142857, and this keeps on repeating. So 2 by 7 will naturally be twice of 1 by 7. That is, if you multiply this number by 2, it will become, so 2 by 7 is equal to 0.285714, and this will be the repeating block this time. So this is 2 by 7. Why I have written these numbers? Just to show you that any number between these two will be between 0.15 and 0.28, let us say. Okay, if you write a number between these, you can achieve the irrational number thing, right? What I mean to say is I have roughly taken the idea where will that number lie. Now if I write a number like this, 0.167800135700 and so on, it keeps on going like this. So this is an irrational number because it is non-terminating and non-repeating. Okay, why did I write 0.16? I got the idea from these two that this number will be between 0.15 and 0.28 roughly. So I wrote this number. Okay, you can write any other number also because we have infinite irrational numbers between these two numbers. So this is an irrational number between these two.